Hello everybody, welcome again to another lesson of understanding math. Today we are going to prove that limit x tending to 0 of sine x over x is equal to 1. And I'm going to show you that using a unit circle. Okay, a unit circle, as you know, is a circle with the radius as 1. Okay, and since we're dealing with the angle x, and angle x is a very small angle, we'll show it by drawing a line from the center to the circumference of the circle. Okay, and we name that as x. Okay, now let me just drop this line here. Let me just drop this line so that we now have a right angle triangle. Okay, and I need to get what is the length of this line. Okay, so from here to here is the radius, so it's still 1. So since we have the hypotenuse and we need the opposite, we'll use sine. So it will be sine x should be equal to the opposite over hypotenuse, which is 1. Okay, hypotenuse is 1, which means that the length of this line will be sine x. Okay, let's just name it AB, line AB. That is the length of this line. Okay, now the next thing we need to do, we need to get the length of this, the arc length. Okay, we need to get the arc length, this part right here. So the formula for the arc length is radius multiplied by the angle. Our radius is 1 and our angle is x. So the arc length is equal to x. Okay, good. So now we have three. We have calculated three lengths: length AB and the arc length. I want to introduce another length whereby a line that's just touching the circumference of the circle and extending, and I want to extend this line so that it meets this line right there. Let's call this line CD. Okay, so we have line CD. For line CD, we want to calculate its length. So how we can calculate? We can use tan, because we have the adjacent and we need the opposite. Okay, so that means that tan of x should be equal to opposite over the adjacent is 1. So it means that the length CD is equal to cross multiply, get tan x. Okay, good. Now we have three lengths here. We have AB, we have the arc length, and we have CD. And now we want to compare them. So from our visual reference from this circle, it is a fact that line AB okay, AB is, it's a fact that AB is smaller than our arc length. Okay, AB is smaller than the arc length, and the arc length is smaller than CD. Okay, just by our visual reference from our diagram. Okay, it is a fact that AB is smaller than the arc length. AB is smaller than the arc length. That is the inequality sign you have put there, and the arc length is smaller than CD. Okay, I hope you can see that. Now we're going to replace their values. So we know that AB is sine x. AB is sine x. The arc length is x, and CD is tan x. Okay, so our initial problem is we're trying to prove that sine x over x is equal to 1. So what we know that x, we want this x to be in the denominator. So what do? We find the reciprocal. Okay, so that we now have sine x, we have that 1 over sine x, and since we are finding the reciprocal, we flip the inequality signs. Okay, so that will be 1 over x equal to tan x is the same as sine x over cos x. So if you flip it, you'll get cos x over sine x. Okay, this is what we now have. So just from our initial problem, we know that we now want sine x to be on the numerator. So what we do is that we multiply everything with sine x. Okay, if you multiply sine x here, you'll get 1. Okay, if you multiply sine x to this part, you'll get sine x over x, and if you multiply sine x here, you'll remain with cos x. Okay, this is what we now have, and now we include our limit. Now that limit of x tending to 0, 1 equals or greater than limit x tending to 0 of sine x over x. This is what we're looking for. Is greater than or equal to limit x tending to 0 of cos x. Okay, so what we now have, since there is no x here, we remain with 1. Okay, we remain with 1 there. So limit tending, this is what we're looking for, limit x tending to 0 of sine x over x. This is what we're trying to prove, greater than limit of x tending to 0 of cos x. Replace x with 0, you get 1. Okay, now this proves that limit of x tending to 0 of sine x over x is between 1 and 1. Okay, it's less than or equal to 1 or greater than or equal to 1. This only shows that if it is indeed between 1 and 1, therefore it must be 1. Okay, so this is our proof that limit x tending to 0 of sine x over x is equal to 1. Okay, so that's how you prove that limit of x tending to 0 of sine x is equal to 1. Okay, thank you for watching. This is Understanding Math.